Good evening, everybody. I am Jayashree from SNS College of Technology, Department of Biomedical Engineering. So, I am going to take analog and digital integrated circuits for the second year's third semesters. So, let us see the topic is what? Full adder, which is under the unit is what? Combinational logic circuits. So, let us see the full adder. So, what do you mean by full adder? And what are the components used before they use the full adder? So let us recall this. So biomedical device before full adder they used ECG analyzers or heart monitors worked with single input signals at a time A plus B. So this is what this A plus B signals, they could not combine multiple biosignals or process prevents patient data states. So we are going for full adder. So this is what empathy stage. So we in the full adder we have the three inputs A, B, C and two outputs sum and carry. So in the empathy stage, we are understanding the user pain points. So understanding the need of the full adder. So manual binary addition with carry is time consuming and error prone. It need to handle carry from previous stage in the multiple bit addition. So we are going for full adder, that is existing half adder is insufficient for cascading multi-bit operations. So in the half adder we have only two inputs and two outputs, whereas in full adder three inputs and two outputs. So in order to overcome the limitation of the half adder, we are going for full adder. So this is what the example of this full adder, that is need of full adder, antigen, serum with antibody and complement. So this all together forms this positive result for the complement fixation stage of CFT. Next, let us define the define stage. So we already seen that in order to overcome the half adder we are going for full adder, right? So similarly here the full adder solves the problem by taking three inputs and producing sum and carry as the outputs. Sum is equal to A XOR B XOR C in and carry is equal to AB plus BC plus C in, where C in is nothing but the additional input is added in the half adder so that we get the full adder circuits. So in the biomedical mapping, so it is what the requirement combine multiple psychological signals with the memory of the past state. So in the pacemaker, decisions are made by combining current heart rate signal, threshold comparison and previous beat history. So that is what output is equal to stimulus signal plus alert or backup control. Next one is what ideate stage. So in the ideate stage we can use the full adder with different types and the idea where we want to implement. Okay, so here in idea 1 multi-bit full adders are used and wearable health monitors and signal fusion in ICU monitors, whereas in heart rate and SpO2 and respiration rate are integrated form of alarms. Next one is what prototype stage. In the prototype stage, so we already defined this full adder, right? 3 inputs, 2 outputs. So that is what we are defining the circuit with 2 half adder. We combine together to form this full adder circuits. So their first box indicates the first half adder and the second parallel box indicates the second half adder, both together to form the full adder circuits with 3 inputs and 2 outputs. And finally, this is what the test stage. Verify the circuit output for all input combinations. So that is what here we already mentioned the 3 inputs, right? So 2 power 3 is what? 2 twos are 4, 4 twos are 8. So we can get the possible 8 combinations from the 3 specified inputs. It also measures the voltage levels at logic 1 and logic 0 to ensure compatibility with ADC and DAC interference used in biomedical circuits. Test performance under varying supply voltage to reflect medical device stability and requirements. So these are the references I referred with for the full adder circuits from tutorial points, from electronic tutorials and circuit designs. These are the full adder circuits. We can refer the data. So thank you all. Have a great day. Thank you.